Hello, welcome to Prajim Technologies. This is Venkat. This is part 3, Built-in Types in C Sharp. In this session, we will learn about different built-in types that are available in C Sharp, escape sequences in C Sharp, and verbatim literal. So first, let's look at the different types in C Sharp, and all these are built-in data types. So the first data type that we will talk about is the Boolean data type. For example, in your application, if there is a need to store a value, of true or false, then we make use of Boolean data type. For example, if there is a question, are you a major, true or false? Okay. So if you want to store values like this, we make use of Boolean data type. Now, to create a Boolean variable, we use the bool keyword, and maybe you give it a name b equals true. Okay, so this boolean data type can only hold true or false. If you try to assign any other value to this variable apart from true or false, then you will get a compiler error because b is a variable of type boolean which can hold only true or false. So for example, if I try to assign an integer to that, a number to that, immediately we'll get an error. Look at that red squiggly line, and it shows, obviously constant value 1 to 3 cannot be converted to boolean, so that's an error. Okay, so but whereas if you look at C or C++, a boolean data type usually contains 0 or any other number. 0 means false and any other number means true, but in C sharp, strictly a boolean variable can hold either true or false. The next data type that we talk about are the integral data types that are available in C Sharp. Now, there are several integral data types as shown in the slide, byte, short, integer, long, etc. Now, all these data types are capable of holding some number. Okay, if you look at byte, it's a single byte, which means 8 bits. Okay, and 8 bits can hold, 1 byte, a variable of type byte can hold a number between 0 and 255. Okay, so which means 0 to 255 are 256 different values. Okay, actually, if you look at how these sizes are calculated, there is a formula behind that. For example, 1 bit, okay, can represent two different values, either 0 or 1, and 8 bits together, they can represent 2 to the power of 8 distinct values. 2 to the power of 8 is 256, and 0, from starting from 0 to 255, is 256 values. So a single byte can hold 0 to 255. So for byte, there is another counterpart, S byte, S standing for signed, meaning it can hold negative values as well. Minus 128 to 127. So minus 128 to, minus 128 to 0 or 128, and 0 to 157 is 128. So 128 plus 128 again, 256. So if it's a signed byte, minus 128 to 127, byte is 0 to 255. Similarly, for short, integer, long, all of them have their counterparts unsigned, unsigned. Okay, so an integer can hold both negative and positive values, whereas an unsigned can only have positive values. It's not signed. There's no plus or minus. It's only positive values. Okay, now, so what's the difference between these different data types? They are from smallest to biggest. For example, byte is 1 byte. Integer is 32 bits. 32 bits is 4 bytes, whereas long is 64 bits. Okay, which is 8 bytes. So in your application, for example, if you're storing the age of a person, most likely couldn't be more than 130, or maximum is 110, 20. Okay, so age of the person is relatively small number. So to store something like that, probably byte is more than enough. Okay, but whereas if you're storing the population of a country, then probably in that case you may choose integer data type because that's a little bigger number, and population of a country is always a positive number, so probably you want to use unsigned integer. Or if it's much bigger, then probably you can go for long. Okay, so depending on the requirement of your application, you can choose the type that is appropriate. Okay, now, is it mandatory to remember all these ranges? I don't think it's practical. Okay, even if you forget the range, even if you don't have MSDN accessible, using Visual Studio you can calculate what is the biggest and smallest number that variable of that type can hold. For example, if I have an integer variable of type I want to find out what is the minimum value that it can store and what is the maximum value that it can store. It's very easy to figure out because this integer type has a property. Again, we will be talking about properties later in detail. So this integer type, so int dot, it has a property called min value. And if you look at the property, this will represent the smallest possible value. This will show what's the smallest possible value that any variable of type integer can hold. So maybe if you want the minimum value, you can just say console.writeLine, maybe something like this, min equals whatever. So now if we go ahead and run this, obviously it will show what's the minimum value. And if you compare this with what's there in MSDN, it is exactly similar. Okay. So that's how you can compute the minimum and maximum. Similarly, if you want the maximum value, it's pretty simple. Use the other property, which is maybe max value. And you want to rename this to give it a meaningful name. So you run that, minimum is that, and maximum is that. All right. So those are the different integral data types available in C#. The next data type that we'll talk about is the floating data type. Float, integral data types, they basically can hold a whole number. If you want, a decimal precision, then that's not available in these integral data types. So if you want, to store some precision values, then you can choose this floating types. Floating point types, we have float and double, and they are much bigger as well. If you look at the float data type, it is basically 32-bit and the double is 64-bit. So they can hold relatively big numbers. And if you look at the precision, they are like 7 digits. After decimal, uh, you know, together with the decimal and you know the integral part, they can be 7 digits, whereas this one is 15 to 16 digits. So that's about float. I mean, basically, if you want precision value, then we can make use of that. For example, double D equals maybe 1, 2, 3, some decimal places I want, and I can do that. And if you just print that number, so but whereas if you do that with a variable of type integer, it won't be able to hold that decimal part there. So for example, if I make this integer in the I, obviously you get straight away an error. Look at this, cannot implicitly convert type double into int. Again, in a later module, we will talk about implicit and explicit conversions. All right, so that's double. Similarly, if you want float, if you want a lesser precision, then probably you can go for float. And the next data type that we have is a decimal data type. Now, decimal data type has much bigger precision. Okay, it has a 29 to 28 to 29 significant digits, and the data type is really huge, 128-bit data type. And similarly, if you want to store any decimal value, you can do so. The type of that is decimal d equals whatever is the decimal value that you want to store. So these are different data types that are available in C Sharp. Depending on the requirement of your application, you choose the data type that is most appropriate. All right. Um, we will talk about the string data type, escape sequences, and verbatim literal in our next video in part 4. Thank you for listening. Have a great day.